Hello guys, today we are going to do this fourth order homogeneous differential equations. First we are going to do the A part, proof x power 4 plus 4x cubed plus 14x squared plus 20x plus 25 is equal to x squared plus 2x plus 5 squared. First I'm going to write down A part. I'm going to let the expression. You see the coefficients of x power 4 is our 1, right? Therefore, we do not need to do anything about it. We can just write this as x squared plus something like ax plus b, and then time, because the coefficients of, when you expand it, you get x power 4. The coefficients of x power 4 is 1. Therefore, we do not need to add in another coefficients, and then plus 2x plus cx plus d, like that. We expand that, we are going to get our x power 4. First you are going to distribute this and then this, right? And then plus cx cubed and then plus d times x squared, and then ax times x squared, which is ax cubed, and then plus our ac x squared, and then plus adx, and then plus our bx squared plus bcx plus bd, like that. And then we are going to group it x power 4, and then look at the coefficients of our x cubed. You can get this is c, a, and then I'm going to write this as a plus c times x cubed. And then look at the square coefficients of x squared. You can get this here and then this here. Therefore you can get plus our don't forget about this. I'm going to write down our AC first. AC plus b plus d times x squared. Look at the coefficients of x. You can get AD, right? AD plus our BC times x, and then plus BD, which is our constant term. And then we are going to compare the coefficients. You can see 1 is equal to 1. We do not need to do that. Do not need to write that. And then you can get a plus c, which is equal to 4. And then our ac plus b plus d is equal to 14. And then our ad plus bc is equal to 20. You can get. And then our coefficients term, which is bd, is equal to our 25. And how should we start it though? This is going to be kinda confusing and hard to solve. Therefore, we are going to do this. By moving alpha, you can get a, b, c, d is equal to 2, 5, 2, 5, like that. And then we are going to plot it back. You can get x power 4 plus our x squared. You can get x squared plus ax plus b. I'm going to write this again. Cx plus d, which is equal to our x squared plus and 2x plus 5 times x squared plus 2x plus 5. Therefore you can get this entire thing squared, like that. And therefore we just prove it. Therefore we can write down this entire expression. Then put down a close parenthesis. Therefore we can call this entire thing x power 4. Because I'm lazy, I'm not going to do it. Just write down this thing is equal to that, which is equal to this thing square. We just prove it. And then Secondly, we are going to solve this fourth order non-homogeneous differential equations by using the inverse D operator method. We have two sessions. I'm going to write it as the first session. We have a line here. Really disgusting. First, we are going to find the homogeneous solution to this differential equation. Therefore, we are going to write down x power. This is the fourth derivative. If you don't like this symbol, you can write it as our four point. Quantable. I think 4 times is called quantable derivative. This notation, if you don't like, you can write the quantable point, and then plus 4y triple prime, and then plus 14y double prime, plus 20y prime, plus 25y. Yes. We're going to solve this e power of negative x cosine 2x like that. Find the homogeneous. Homogeneous. Another pronunciation is homogeneous. Write down as our. We are going to write the characteristics equation first. M power 4 plus 4m cubed plus 14m squared plus 20m plus 25, which is equal to 0. And then we just prove this entire thing, which is equal to that thing, but here we are going to use the variable m. M squared plus 2m plus 5 squared is equal to 0. Whenever you see something like this, something square is equal to 0, first remember to remind it has a double repeat root. You need to remember. First, we're going to square both sides. You get m squared plus 2m plus 5 is equal to 0. And then when you use our calculator, you can get b squared. We're going to find the delta. When this delta is a negative number, you can get our complex solutions. And then b squared, which is our 2 squared minus 4 times our 1 times 5. Use our calculator. 2 squared minus 4 times 5. You can get negative 16. This is less than 0. Therefore, we have to use our quadratic equations formula. Yes. First, you get negative b squared, which is negative 2 plus or minus, and then we already find the b squared minus 4c, which is negative 16. And then divided by 2 times a, which is 2 times 1, which is 2. And then we are going to simplify it, and then the square root of 16 is our 4. And then have a negative side, therefore we have to add I here, and then divided by 2. Therefore you can get two solutions. Negative 1 plus or minus 2i. And remember, it has double repeat root. We have to write it like that. Double repeat roots. Whenever you are going to do a double repeat roots characteristic solution, yes, we are going to write down the original negative, and then negative 1, which is our alpha. This is our alpha part, and this 2 is our beta part. Remember the formula. First you will get e power of alpha, which is negative 1 times x, and then time our c1 cosine, and then the beta x, which is 2x plus c2 sine 2x. And then because we are going to deal with double repeat with situations, we are going to add another solutions, which is x times that. Whenever you are going to do a double repeat roots, and then the nth repeat roots, this is the formula. Nth repeat roots, we are going to multiply by our x power of n minus 1. Because this is a double repeat roots, we are going to multiply by our x power of 2 minus 1, which is x power of 1. these functions and then times this entire functions. However, the C1, C2 we have to change it to our C3 and C4 because the constants are not always the same. We have to use another constant, C3 and C4. You can get x times e power of negative x like that. And therefore this is our first part. We already solved this. Really cool answers. And then we are going to do our second part. We are going to solve this by using our inverse the operator method. Therefore, we are going to write this as our d power 4, 4 power, 4th power, and then plus 4 plus 4d power 3, 14, 20, 25, like that. 14 and then plus 20 and then plus 25. We have to use our yp because we are going to find the particular solutions to this. Use our yp. We are not 1. We are going to set this equal to our e power of negative x cosine 2x. And then we already proved this is equal to our d squared and then plus 2d plus 5 squared. Write this like that, which is equal to that thing. And then we are going to divide it by that on one side. You can get 1 over parentheses 2 squared plus d 2d plus 5 squared, which is, and then times e power of negative x times cosine 2x. And then we are going to use our exponential switch theorem. First, we are going to put down e power of negative x in front, and then look at the coefficients of this x, e power of x, and in front of the x you can get negative 1. Therefore, we are going to write this. Replace this d with our d minus 1 square plus 2 times d minus 1 plus 5 square times cosine 2x. And then we are going to simplify this expression times this entire thing. You can get, first you are going to get d squared minus 2d plus 1 plus 2d minus 2 plus 5. And then you can get d squared, and then negative 2d and positive 2d get cancelled. And then you can get positive 4, d squared plus 4 like that. Time. Yes, we cannot apply our differentiate rule here because this rule is only applied in our simple roots. Therefore, we cannot use this differentiate formula, and we just get a one particular solutions. We have to do it once again, guys. This solution is absolutely wrong. That rule is only acceptable for our simple expression, simple roots, not repeating roots. Yes. Therefore, we are going to 1 over 2a x times our sine ax. Whenever you are going to do something like that, and then let's differentiate both sides. We differentiate both sides, and then you can get respect to a, and then ignore this thing. Only do a derivative of this and then that. Use a symbol. Yes, d. I think we choose a partial derivative. Apply a partial derivative on one side. First thing, you are going to get 1 over d squared plus a squared and then square. First thing, you're going to square that and then take a negative sign. And then here, I think I made some mistake here. And this thing, it should be our a. And this thing should be our 32. Not 32, it should be 24. Multiplied by x cubed. This is kind of tough, therefore, sorry, I'm going to apologize. And then, how can we do this though? And then, a squared, a times our 4, which is 32. And then this thing, you can get 24 times our 24 times 2 cubed. This kind of, it should be 24a. Yeah, 24a is the root. v1, and then after multiplying you get 1 over 48. Therefore you can get something like this: 1 over 32 x squared e power negative x times cosine 2x plus 1 over 48 x times e power negative x. It should be x cubed. First you get x squared and then x cubed like that. Finally, we can just write down the solutions. This is really complicated. You can see these partial solutions. Therefore, you can get something like this. Why this general solution is equal to, I remember this is e power negative x times c1 cosine 2x plus c2 sine 2x, and then plus x times e power negative x times our c3 cosine 2x plus c4 sine 2x, and then plus another, right, plus our general particular solutions. A really confusing one, you can see. 48 x cubed e power negative x sine 2x, and therefore this is our solutions. Really crazy. And thanks for watching, and stay tuned for more quality videos by me. Bye.